Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, Managing Editor at MediaOps and moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you missed any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have 2 polling questions during today's webinar, so hopefully we can get everybody engaged. And at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is securing your AWS deployments with Spinnaker and Armory Enterprise. Our speakers today are Paul Roberts, who is Principal Solutions Architect at Amazon Web Services, and Lee Faust, who is Field CTO at Armory. Welcome, gentlemen. Thank you so much for joining me today. Appreciate it. Paul, I know you are going to be kicking off the conversation, so I am going to put myself on mute and let you get right to it.
Great, thank you very much. Happy to be here. Good morning, good afternoon, good evening. My name is Paul Roberts. I'm a Principal Solutions Architect here at AWS. And as was previously mentioned, we're going to be talking to you all today about securing your AWS deployments with Spinnaker and Armory Enterprise. Also with me is Lee Faust, Field CTO at Armory. And we're going to be going into a number of topics that we're really excited to share with you today. So the first thing that we wanted to dive into was Lee, next slide, please. The first topic was, why did AWS get involved? And the first piece is that we have this philosophy where we want to go where the developers are. And what does this mean exactly? So at AWS today, we have over 175 different services, and this covers services that are focused on virtual machines, functions, containers, and even serverless containers. And what we realized was that our customers were looking for ways that we could simplify interactions between our different compute primitives. And we began looking at tooling that could solve with this challenge. Lee, next slide, please. And as we began this journey, we realized that we had a deep partnership with Netflix. And when we began diving deeper into everything that they had done to help their developers be more efficient, we realized that they had an open source tool that they had built called Spinnaker. And due to this, Spinnaker today is integrated with a wide range of AWS services, as previously mentioned, between our containers or VMs or even functions. Next slide, please. So as we began our journey, before we wrote any lines of code, the first thing we wanted to do was, how could we help the community? How can we make it easier for the community to work with Spinnaker on AWS? So we began focusing on documentation. And this documentation journey took us on a path where we actually published well over 6 blogs. We updated the documentation on the Spinnaker website that helps folks install Spinnaker on top of AWS with both EC2 and EKS. And there's more blogs coming out. We have a huge backlog of content that we're looking to publish. Lee, next slide, please. So some of the things that we focused on beyond creating any of the documentation was doing new service integration. And as I mentioned, Spinnaker already supports containers, technologies like Kubernetes, but customers began asking for, what about things like serverless containers? How can the community help remove the heavy lifting of having to actually manage a container platform? And this is where Fargate comes in. So a couple years ago, we integrated Fargate, and this is with a good friend of mine, Claire Liguri, who actually sits on the technical oversight committee representing AWS. Next slide, please. One of the most exciting things, and one of the things that we're most proud of here at AWS, is that when we looked at the Spinnaker landscape, we realized that there were a number of compute primitives, but one of the compute primitives that was lacking was there was no functions integration. So we set down the path, again, about 2 years ago to integrate functions and create a new compute primitive, which is functions as a service. We ended up writing well over 2,000 lines of code. And this is actually gaining a lot of momentum with some of our largest customers. And we have some additional work that's actively ongoing. And if you sit tight, you'll see some PRs and some additional enhancements that will be coming in the next 60 days or so. Next slide, please. I want to highlight that, again, we're working with containers and functions, but specifically with Kubernetes and Kubernetes integrations, EKS is supported and works very well with the Spinnaker platform. We've done a lot of work at reInvent when we have our different events and workshops with our customers. And one of the things that we demonstrated last year was easily being able to scale up your application with a couple clicks with Spinnaker. And this was going from 3 pods upwards of 500 pods. So scaling was extremely simple and very easy to use with the platform. Next slide, please. So one of the last things that we did was we looked at, the Spinnaker, it integrates with many different platforms, and we wanted to explore adding a pipeline stage that could offload code compilation to one of our managed services, and that's code build. And with code build allows you to submit jobs to do your code compilations, and you no longer have to worry about spinning up additional workers. You don't have to configure anything. You submit your jobs, and everything automatically scales. It auto scales up for you as the job is running, and everything contracts when you're done running your job. And with code build, you only pay for what you use, so it's very efficient. And if customers don't want to use code build, they can leverage existing tooling like Jenkins, but this was a recent addition that we added, and we're actually seeing some decent traction from this as well. Lee, next slide, please. So with that said, I want to focus on delighting our customers and things that we've done here at AWS to enable our customers to achieve better support with Spinnaker. And first and foremost, I'd like to introduce Lee Faust at Armory. And Armory is a fantastic partner of AWS's, and Lee is going to take you on a journey describing what they do with Spinnaker.
Paul, thank you so much. Really appreciate the introduction. As Paul said, my name's Lee Faust. I'm a field CTO here at Armory, and I work with a lot of our enterprise customers on simplifying the deployment process of their applications. One of the things I want to do is we have our first polling question that I would like for us to go ahead and create some interaction with the folks that are on the call right now around what sort of compute primitives are you guys currently deploying into AWS?
Yeah, so the polling question should be on your screen now. The question is, what compute primitives are you primarily using? You can choose between containers, VMs, or functions. And while the audience is making their selection, just want to quickly remind you that today's event is being recorded. So if you miss any or all of the event, or if you just want to watch it again, you'll be able to do so following the webinar. We will be sending out an email later on that does contain a link to access the webinar on demand. So fear not if you miss any part of it. Okay, looks like we are getting to close to the end here. I'm going to go ahead and close out the polling question here in 3, 2, 1, and then we'll take a look at the results. Looks like the majority of folks are still using VMs.
Great. It's great feedback for both the AWS team and from the Armory team of where we should be focusing some of our efforts moving forward. So as Paul had described, let's see here. As Paul had described with code build, we have a lot of our customers where they're building out these software factories. And software factories was initially described to me back in early 2000s from a gentleman named Jack Greenfield, who was working for Rational at the time. And he and I started talking about the idea way back when we were still using Hudson about the ability to create these factories that took our ticketing systems, our code change sets, and the build artifacts that were coming out of our applications, and then being able to talk about what those things look like beyond the artifact, which was still relatively new. We had a lot of people building things like jars, wars, ears, and they were deploying them to places like WebSphere ND or BEA WebLogic. And a lot of these technologies were just starting to look at using VMs. A lot of these applications were still being deployed to bare metal. Well, now that we've gotten to a point with the great services that exist from Amazon with AWS, we can go ahead and talk about being able to use software to describe our infrastructure and our platforms that allow us to streamline the deployment of these applications. And this is where we see a lot of our customers getting to today, is they go ahead and they create their artifacts, and those artifacts now are beyond just jars, wars, and ears. And now we have things where we're deploying them as container images. And those container images, we have a group of microservices all described as individual images that end up making up an application. And then those applications ends up consuming resources from our platform. And our platform is made up of many resources that we're able to provision on the fly using things like CloudFormation or Terraform or Ansible. And those things can be automated and deployed as well as part of this deployment process. Now, when we look at this, one of the biggest questions that we get from our customers is, because this artifact is the union between the code creation process and the code deployment process, a lot of our customers are trying to shift the onus of the deployment into the developer's hands. Now, the developers not only now are required to understand how to provision resources, but also the middleware. So they're responsible for maintaining the database changes, for building out their Kafka clusters, and defining the schemas that need to be deployed, or defining new API gateways. So as they start to do these things, we need to create some sort of road forward for them to self-service into. So what we've done is, a lot of our customers have given their CI tools that they've given to their app devs, and they've gone ahead and they've done a great job of creating the artifacts. And these artifacts are being deployed today into non-production environments. When we do this from our CI tools, a lot of times we create this sense of security that what is deployed in non-production can also be deployed into production. So we see a lot of issues with that particular model, where the people on the left-hand side create these validations, and their validations are based on assumptions that the environment on the left is identical to the environment on the right. When we go ahead and look at the challenge that we're seeing, is the app devs and the QA teams, they have a thumbs up that everything is good, and the validations are all passing. They're using tools like SonarQube and CodeClimate and looking at the unit test frameworks, and they've got their artifacts that have been built, and maybe they've created some manifests for deploying into EKS, or building a VM and deploying the objects into those VM environments. Unfortunately, when they get ready to deploy into production, they're given an answer that is they can't move ahead because the application does not adhere to compliance or regulatory guidelines. And they end up in this situation where the app devs they don't know how to move forward. So as they look at the different processes around this validation, we see a lot of our customers that, to be able to get the app devs to understand where the security rules are broken down, is through things like architectural review boards, or through change management processes where we have change and security reviews. And a lot of times inside of organizations, this may be done once a week. This could be done once every other week. So if these change review boards, no matter how well we've done in our app dev environments, these change review boards are blockers to getting us into our production environments. If we go ahead and we're denied access to production from that change review board, if we're doing things in a sprint model and it's taken me 3 weeks to go off and build something, and then I hand that off to a change review board and they tell me that I am being denied access in the next release cycle, that could take me another 3 to 6 weeks until I can get back in front of the change review board again. So that means that the changes that we're trying to iterate on quickly and trying to increase the velocity of our work, we end up in a situation where you could be sometimes 3 to 6 weeks behind the original development of these particular items, meaning that everything that we're trying to fix is now backlogged, and those backlogs end up creating frustration, and that frustration ends up leading into a lot of finger pointing when there are errors or issues inside of our production environments. So how can we go ahead and solve some of these manual processes? So when we talk to our customers, they relate a lot of the DevOps initiatives inside their organizations as a combination of people, process, and tools. Now, there are so many tools inside of the DevOps landscape today that what we want to be able to talk about as the second half of this presentation is we want to break down the tools and we want to move to talking about rules. The reason why is we've done such a great job inside of our organizations of shifting our quality processes to the left, and we've integrated them into the app dev process, into that sprint planning process, that what if we could take our security processes and move those to the left as well? A lot of people refer to this as DevSecOps. And we believe that integrating security into that sprint deployment process, that we can go ahead and provide visibility that we've never had before, creating a collaborative environment between our app devs and our security teams so we can know where things are breaking down. So the way that we do this is by taking these policies and we codify them and share them to the app devs. And when we do this, we're able to see things inside of our organization that allows us to know when we are potentially breaking compliance, when we are not adhering to best practices, and those things end up leading into a lot of really interesting conversations inside of an organization. One of the examples I like to give is I came to Armory from GitHub. And when I worked at GitHub, I remember the first few presentations that I gave, I was a huge fan of the pull request process. And when I would go and talk to organizations, I would ask them how they use pull requests in their organizations around being able to create a collaborative environment. And one of the things that I found out is the developers would wait until everything is all buttoned up and everything is all code complete, and then they would open up a pull request. And they were looking for that pull request to be an immediate validation and approval for them to go ahead and merge that change back into master. That mentality is going against the reason why pull requests were developed in the first place. Pull requests were really developed as a collaborative mechanism that after your first small commit, you push it to your branch, and then you open up a pull request to start a conversation with those people that will be impacted by the change that you're about to create. We want to create that exact same type of collaborative mechanism as part of your deployment process between the security folks and the app dev folks. So in this specific example, in a non-production environment, it may be okay for me to open up port 22 in a VM or inside of a service to a container, because the developers are trying to understand how the environment variables have been configured. They might need to see how the file system is laid out. They may need to know what other services are installed inside of that VM that they can take advantage of. When we do that, we end up creating model where port 22 will absolutely not be acceptable for us to go into production with. So when we do this, we can give a warning to our app devs in a non-production environment and say, hey, I'm gonna let you know that if you try to move forward into production using this configuration, it's going to fail. A lot of times our customers are wanting to templatize their deployment process that they use a lot of variables. So I don't actually know that port 22 is going to be exposed until I actually instantiate that particular job or stage inside of my deployment process. And at that point in time, I need to be able to block it. So when we do this, we're able to create this visibility where normally we don't have our app devs are trying to do nefarious things inside of our production environments. What I've seen is a lot of people, there's not a lot of bad actors out there. A lot of times it's really about information. And the policies that we end up creating inside of our organization, some of the companies that I've worked at, the policies are still in 3-ring binders. They were printed out, physical paper, and it's locked away in a CISO's office or in a security wing that very few people ever go and talk to. What's even worse is when I go ahead and I've taken the time to go ahead and take those policies and then I store them into a wiki. And then what I do is I secure the wiki. So the only way I can see which policies I have access to is I have to open up a ticket, I have to be granted access, and a lot of times that access is only granted in a temporary fashion. So I don't know which policies I might actually be violating when I'm trying to go through a deployment process. So here, when we have this policy visibility inside of our organizations, I can sit there and just like inside of a pull request, oh, that's right, I shouldn't have done my for loop in this way because it's going to create a memory leak. I can use that exact same mentality when I'm going to deploy, where I can say, oh, that's right, I opened up port 22, which needs to be closed because I don't want to allow global access to the specific resource that I'm about to deploy into production. So what does this mean for our deployment process? So when we go through, we talk about maturity levels for a lot of our organizations that we work with at Armory. And what we're able to do is we're able to talk about this maturity level from 1 to 5. So the first thing that we do is a lot of our organizations are very hesitant to move away from these manual change review boards. But right now, there's release managers or SREs that are still going around and filling out Excel spreadsheets. They're going ahead and they're interviewing people. There's a lot of meetings that go on, and it takes time away from the developers and from the QA teams and from the operations teams to going off and doing more strategic work. So if we could build a process that allows us to collect a lot of the data that would normally fill in those Excel spreadsheets, and we could expose that data to the change review boards up front, that they could get an audit report or they could get a policy report that shows them what state the current application deployment is in, they could immediately say yes or no based on that data. And I don't need to go through that manual process of having to go through and talk to everybody. The maturity level, as we move across from 2 to 3, we end up getting to a point where now I've got all of my policies have now been codified. And I might have other things that I've tied into my policies where I'm doing advanced decision support. And I might have canary analysis, I might have a set of quality gates that are passed through my policy engine as well, that when all of those things are aggregated together and I have a good sense of data, I can give control over to somebody who is responsible for the deployment. Now, to be able to adhere to things like Sarbanes-Oxley and other types of compliance issues, the person who's releasing the code into production has to be somebody different than the person initiating the deployment. This is one of those things that a lot of companies have done with ITIL, using their ITSM tools. What we want to be able to do is, instead of going through that manual ticketing process, we can go through and put the control of that deployment through something like a manual judgment, that I can take that particular release model and I can give them the control to say, it's Wednesday morning at 10 a.m. and I've got a set of code that's ready to get released. I can shrink down the blast radius of an individual deployment, and I can see all of the corresponding data that allows me to make an informed decision. So I still now have a manual process, but I've given you some guardrails to be able to make better decisions about that deployment. Now, a lot of times our customers want to get to a point where they're doing true continuous deployment. So now the engine that's driving all of that data and analytics, they take that information, and based on those guardrails, they can just let somebody immediately deploy, or even letting a service account or a chatbot that, based on that data, lets us know that we've already done a deployment. And one of the things that I tell a lot of our customers is, you'll know when you're getting Agile and DevOps right, when instead of talking about at the beginning of a sprint planning session or at the beginning of a stand-up meeting, instead of talking about what I did yesterday, what I'm going to do today, and what I'm targeting for the rest of the week, is I can talk about what we deployed yesterday, what we're going to deploy today, and what future deployments do I have. Now what I've done is I've created this sense of being able to show the impact of what I've created, rather than talking about a goal that I'm hoping to achieve by the end of the day. Now these teams, as you create this consistent policy enforcement, I can build these policies where I can stack rank them. So I can have some policies that are across the entire organization. There are organizational best practices. I can also filter those policies down, that I could have specific pipelines that I want to target, where I might have my shopping cart, credit card transaction process, that I can go ahead and say that needs PCI DSS. So for that, those pipelines, I can then have a specific set of policies that only map to those specific delivery models. Same thing for things that might be FedRAMP or different FISMA policies that we might have to adhere to. Now, policies are not static. So a lot of times there are different auditing rules that change from year to year. And to be able to model those things out, sometimes we have to go from a pure continuous delivery model, where we may have to go back and put those training wheels back on again. So now what we could do is we're training our app devs in the new model, so they know what things they need to change. And then they get to, once they get comfortable and we have built up that confidence that they know what rules need to be applied, then we can go back in and do a regular continuous delivery model. Now, from here, one of the things that we see is, where are we actually deploying these artifacts to? And a lot of our customers are going through some sort of app dev modernization practice or some sort of cloud migration practice. And as they go and they do these things, they're breaking up their applications. Now, what I'd like us to do is, we have a second polling question that I would love for us to go ahead and open up.
Okay, the polling question should be on your screen now. The question is, do your developers have access to modify production resources and applications today? You can select from a simple yes or no. And while you're doing that, I want to quickly remind you that we are taking questions from the audience. So if you have a question for either of our speakers, please, you don't have to wait until the question and answer period. Go ahead and use your GoToWebinar control panel and submit your questions, and we will try to get to as many as we can near the end of today's webinar. All right, let's see. We have a healthy amount who have voted already, so I'm going to give you guys about 5 more seconds before I close it out, and then we'll take a look at the results. Okay, I'm closing them out now in 5, 4, 3, 2, 1. Okay, here are the results. Looks like the majority of folks have a big healthy no.
So this is normal with what we see with a lot of our customers. I am actually surprised that a third of the respondents did say yes, that they do give app devs access to their production environments to control that type of deployment. So that's awesome to see that some of the people who are actually on this call today are already at a maturity level of a 4 or a 5 from what we just discussed. Now, when we talk about being able to do a consistent deployment, what we want to do is we want to make sure that we're enabling cloud best practices. So when we talk about cloud migration best practices, we usually end up in this situation, and I usually joke with our customers that when we're talking about things like AWS, you can't contact somebody like Paul and ask him and say, hey, Paul, could you give us a different costing estimate for our US East 1 region that only needs a 95% uptime and charge us less? Everything inside of AWS is always going to be production ready. So when we do this, it doesn't necessarily make a ton of sense for us to talk about things between non-production and production environments. So we end up in this situation where we create this nesting doll effect. So we have our cloud provider, and then we have our company as a tenant, and then we break up that company into a series of projects. Inside those projects, we usually have many applications. Those applications get deployed into different environments, non-production and production. And then we have a number of resources that we consume inside of each one of those environments. And as we navigate through each one of these different segments of our deployment process, we end up getting to a point where we have to make a set of decisions about, can I move a particular artifact from non-production to production? When we do this, a lot of times our customers want to be able to know who deployed what. So this particular pull request in GitHub is mapped to what release that is sitting in a specific environment. And when we do that, we usually do that through things like tags. So when we create tags, we need to have some set of naming convention. Well, who says what the naming convention can be, and who validates those naming conventions when we go ahead and talk about doing things like automation? A lot of times this is done team by team. We don't have a consistent way about how we go ahead and trigger things into our different environments. And this is where your continuous delivery tool really comes in handy. So when we talk about whether it's infrastructure as code or continuous integration or continuous delivery, or even if you've gotten to the point that you're doing pure GitOps, one of the things that we see is people wanting to deploy these things as a single unit of work. And as they deploy these things, I can validate that the infrastructure that I require for my application is still meeting the compliance requirements that I need for go live. And what I mean by this is, as an example, I'm provisioning an S3 bucket. And let's say I go ahead and I've done it correctly. My policy through Spinnaker has already validated that, hey, you have done this correctly, you've met the corporate compliance, but then somebody decides to log into the AWS console and they make a change to that S3 bucket and they make it publicly accessible. Well, the next time I go through and I do a production deployment, I can have my tool that's using that deployment look to see if there has been a change. So inside of the Armory Enterprise, one of the things that we have done is we have gone ahead and we've built out a model with Terraform where you can run Terraform scripts alongside deploying your application. So as we're establishing those dependent resources, I can policy enable those inside of my traditional pipelines. And now when I group those things together, I can see through a Terraform plan, I can see that somebody has made a modification through a Delta. and I can make sure that I change that resource back to the model that I need for compliance. What this does is, as I link all of these things together, I take the data that I get back and I can use those things as variables that I can pass to other stages of my deployment. So now I could get the S3 bucket name, I could get that and pass that along to a deployment and use that as an environment variable that then is consumed from my application. There's a lot of different ways that we can configure these things to allow us to shrink the blast radius and make sure that we're adhering to best practices from a compliance perspective. The other thing that is really powerful inside of Spinnaker is one of the things that Paul was describing earlier in the presentation. When you go into Spinnaker, you have this infrastructure tab. And inside of the infrastructure tab, what we do is we create a server group. And these server groups allow us to take the metadata that I would normally use inside of the AWS console. And instead of me having to go through a wizard and choosing all of the different settings, which I could absolutely put in the wrong value, I can use a set of defaults. And then every time I deploy to that server group, I'm going to inherit those reasonable defaults. So now when we talk about things like key value pairs to be able to go and create those queries, I'm able to come back and be able to say, hey, I want to make sure that this application going through and doing a deployment is using a consistent set of key values. The other thing is because we're reading this as metadata throughout the pipeline process, if somebody did create a server group that didn't have a set of key value pairs that are required for us to go and effectively do a good deployment, we can fail the deployment and tell somebody to go back and modify the server group to go in and add those defaults for those different tags that we can then use to query, so we know which applications are consuming which resources inside of AWS. The great thing about AWS is these specific tags are used across everything that I can provision. So it doesn't matter if I'm deploying a Lambda function, it doesn't matter if I'm deploying an ALB, all of those resources can all be tagged and allowing me to be able to have visibility to those resources from inside of Spinnaker. These defaults that we have don't just apply to things like tags. Things that I can do is, what is the IAM role that every EC2 image should inherit? Do I want to make sure that I am associating public IP addresses? Do I want to set things like what is the default key name so that way people can access it via SSH? You can also go through inside of these settings. There's a scroll. If I scroll up, there's other things around firewalls and load balancers that I can inherit, so I can make sure that I'm creating defaults where I'm making sure that I'm not opening up port 22 to the world. Now, from these reasonable defaults, the great thing is that when I combine the Armory policy engine with Spinnaker with these reasonable defaults and the power that exists of being able to query all of these resources as I'm consuming them inside of AWS, I'm able to create a consistent deployment. This consistent deployment allows us to be able to create easier transition between teams. We have a faster time to resolution. We're able to create higher uptimes and more time focused on strategic work. And most of the executives that we talk to, these are some of the things that are really the driving factors as we move forward into these cloud and hybrid cloud type environments that allows teams to be able to move much faster. And here you can see a sample Rego file, which is how we define things with the policy engine at Armory, that we can go ahead and here you can see something like, I expect a set of required labels. And if those labels don't exist, I can deny that specific deployment and ask somebody to go ahead and add those in as part of the deployment process. So with that, I want to thank everybody for joining us today, and I'd like to open it up to any questions that we might have.
All right, great. If you have a question, please go ahead and use your GoToWebinar control panel. Let's see, looks like we have one question here for you. What compute primitives do you see customers using predominantly with Spinnaker?
Yeah, what a great question. So I'll answer first, and then I'll let Paul, because I know they can see some things on their side inside of AWS as well. We see a healthy mix between EC2 and EKS, and we're seeing a bit of a rise with some of the people also using ECS. So those folks that are probably just starting their containerization journey, we see them move from EC2 to ECS to EKS. And then we are starting to have a few customers, especially those that are doing high machine learning workloads or batch type processes, where they're starting to pick up doing more and more with Lambda. I'd love to hand it over to Paul to see what he might be seeing on his side.
Yeah, Lee, thanks for that. You kind of read my mind, to be honest. I think there's definitely, as Lee said, a healthy mix between the virtual machines and containers. I would say is that we are seeing more growth on the Kubernetes side within EKS, but there is still a lot of users that are using EC2 primarily.
Excellent, excellent. Okay, let's see. Next question for you. What patterns or workloads do you see customers using with Spinnaker?
Yeah, so the different patterns that we see is there's what I call a continuous delivery model to non-production. So there are not a lot of gated controls. And then we see more release orchestration type patterns as we go into a production environment. And then that is where that bridge is, where we want to be able to have the decision support system that allows us to know what artifacts that we've created in non-production are ready to be released into those production environments. And those patterns that we see are a really interesting mix of the different resources that are being consumed and different varying levels of automation. So things like infrastructure resources are a lot of times being provisioned, sometimes way ahead of the application ever consuming them, which from a cloud perspective, as soon as we go and create a resource, you're going to start being charged for it. Also, there's a higher risk of that particular resource potentially becoming out of compliance as we provision those things earlier, because we're not iterating on those things faster. So when we go ahead and create a pattern where we're deploying the resources, the middleware, the application, we're doing that as a single unit of work, then what we're able to is consume those resources just in time and making sure that we're meeting compliance all the way from the application down to the infrastructure resources.
All right, great. Okay, quick reminder, guys, plenty of time for questions. So if you do have one, please go ahead and use your GoToWebinar control panel and submit it. Next question, how do customers approach securing pipelines?
What is the best way to secure pipelines? So inside of Spinnaker, Spinnaker has a service that allows us to be able to implement RBAC controls. So what we have is we have a way for a user to get authenticated, and then at an application level, we give authorization. And the authorization is done between a combination of read, write, and execute. And along with those, each one of those different patterns maps to both the pipeline level and to the infrastructure level. So because we're defining a service account that's going to go and provision our resources, sometimes we may not want to give specific users read access to the infrastructure that's been created. especially for some of the production environments. There may be sensitive information that may exist in some of the metadata. Now, when we talk about securing pipelines themselves, a lot of times what we see our customers do is they use the Armory pipelines as code capability. And when we do pipelines as code, we're then passing the definition of the pipeline into our source code control. And then from the source code control, we use that process to validate the pipeline, and then we pass that back into Spinnaker upon merge back into a master branch. And when we do that, we're able to go ahead and lock the pipelines inside of Spinnaker itself. So now only an admin could go in and unlock that pipeline. The other thing that you can do is we can also use the policy engine to create guardrails. So we can do things like making sure that a specific stage exists inside of a pipeline, or you won't be able to save it. And the real power is when you combine those two items. So when you take our pipelines as code to templatize your pipelines, and then you use the policy engine to make sure that nobody is trying to inject variables that would end up breaking your deployment process, those two things make a very powerful mix.
All right, great. Next question here. Can I run Spinnaker locally on a laptop?
Sure. You're going to need some horsepower to be able to do it. One of the things that we've done is we've created something called Miniker. So if you go to the Armory organization on GitHub, you will see a repository for Miniker. There's some really good documentation in there. You're going to need between 10 and 12 gig of memory to be able to run it. And to be able to do that, what we can do is we run Rancher K3s. So Spinnaker runs inside of Kubernetes, and we'll deploy the Spinnaker services into K3s. And then what you can do is you can play around with it. Everything can get enabled. You can also even run the Armory version and play with the policy engine and see how that works internally without ever even needing to contact a salesperson or anybody else.
All right, excellent. Once again, guys, plenty of time for questions. So if you do have a question, don't be shy. Just go ahead and put it in the GoToWebinar control panel. Next question here, does Spinnaker work with Azure DevOps for those organizations that use Azure DevOps?
Sure. So when you look at the definition of the for the source code mapping, it uses pure Git. So we're not tied to the GitHub APIs or the GitLab APIs. So what you can do is inside of Azure DevOps, you can create a personal access token that will then allow you to be able to authenticate into Azure DevOps to pull the source code in. Some of the things that you may want to do is if you're also going beyond and using the Azure build tools, you can also do the builds and store your artifacts into the different repositories that exist. The great thing is we have a lot of our customers today where they're more than just single cloud enabled. So a lot of times what we'll see is we'll see people who are running Spinnaker with our assistance where we're deploying, pulling code from Azure and then deploying specific workloads into AWS, as well as deploying specific artifacts into GCP. And this is really powerful when we start to look at the ability to be able to transport workloads across Kubernetes clusters. So now a Docker image should, for all intents and purposes, run in either AKS, EKS, or GKE. So lots of really interesting use cases around that.
Excellent, excellent. Okay, we have one more question here, but if we get any more in, please keep sending them on in. We'll keep going as long as we can. What is the easiest or fastest way to get started with evaluating Spinnaker?
Yeah, so there's a couple of ways. So A lot of our customers that we work with at Armory, they like to be able to get started with somebody who can provide them some general guidance. So a lot of times what we'll do is we'll do free POCs. So you can do that by standing up Spinnaker inside of an EC2 environment and just going ahead and doing some basic deployments. As you start to get beyond doing basic deployments, if you're really serious about wanting to potentially move Spinnaker into a production environment, then usually the solutions engineering team at Armory get involved. And what we'll do is we'll work with your team to go ahead and do more of a production-like deployment into something like EKS. And we'll talk about best practices, and we'll go ahead and we'll even work through setting up authentication, authorization, so you can see what a true production Spinnaker deployment looks like. We've had customers that have done complete evaluations in as short a time as a week, to other customers that are just sort of dipping their toes in the water, and we do weekly check-ins with them, and we use tools like Trello and GitHub, and we collaborate asynchronously. And what we'll do is sometimes those will take, sometimes 4 to 6 weeks. But you can start anywhere from going off and grabbing Spinnaker and just going ahead and going off on your own. There's some great documentation on the Armory website as well as on Spinnaker.io, or feel free to reach out to us at Armory and we'd be more than willing to do a free POC with your team.
All right, great. Well, that is all the questions that have come in. So I'm going to go ahead and close out the question and answer period. If you do have a question you want to ask, go ahead and still submit it in the GoToWebinar control panel. And if we get it before the end of the webinar, then I'll be sure and ask the guys. Otherwise, I'm sure somebody will be more than happy to follow up with you offline to get your question answered. Let's see. Oh, we just got one. Okay. Does Spinnaker work with OpenShift? I saw OpenShift available on AWS.
Lee, I'm going to throw that to you. I don't have any experience with OpenShift on AWS myself.
Sure. So we do have a few customers that are starting to evaluate. There's a managed OpenShift from the Amazon folks. And we have had a lot of success using OpenShift on-prem. So a lot of those customers that are looking to create a hybrid model between both consuming AWS as a platform, as well as being able to maintain some security behind their own four walls, we're able to establish that link using things like private VPCs and VPNs to allow you to be able to communicate. Maybe your database needs to be on-prem, but you want to run your stateless workloads inside of OpenShift inside of AWS. So we can absolutely go ahead and pull those things together.
Excellent. Excellent. Okay. All right, great. Well, I'm going to go ahead and close out the question and answer period now. It's 7 minutes to the top of the hour. I do want to thank everybody who did submit questions. And as I said before, if you do have a last minute question, go ahead and add it, and then we'll be more than happy to forward it over to the guys at Spinnaker or at Armory and AWS to get your question answered. All right, quick reminder also that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go find it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, at the top of the hour, I did mention that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let me go ahead and do that. Our winners today. First winner is Eric F. Congratulations, Eric. Our second winner today is Crystal Crystal T. Congratulations, Crystal. And third winner today is John W. Congratulations, John. And our final winner today is Michael N. Congratulations, Michael. We'll be following up with all 4 of you offline by email to get your Amazon gift card over to you. And if you don't, so check your inbox, but if you don't see anything there, please check your spam folder. Lee and Paul, what a great presentation. Thank you so much. Lots of really great information, and judging from the quality of the questions that came in, I know the audience got a lot out of it too. So thank you so much for your time and your expertise. Really appreciate it.
Great. Thanks
Thank you for
everybody.
having us.
Yeah. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.